So yeah, my name's Will. I've been writing Go code in like a professional setting for about 2 years, and I thought, I've learned a lot over the course of working, and I thought what would be some useful ideas that I've developed over the course of my time writing code, writing servers, writing APIs at Hootsuite. So yeah, basically, I feel like I have learned a lot, and a lot of that knowledge is sort of trapped up in like private GitHub repos and stuff. So I didn't want to just get too much in the weeds here. So I thought, can I abstract away a little bit and think, what are some interesting design principles that I've learned for writing APIs in Go? And to do that, I'm kind of riffing on this idea of the solid design, object-oriented design principles that were first created by Uncle Bob Martin. So yeah, so basically SOLID's an acronym. It refers to a set of principles that were first popularized, I think maybe invented by Uncle Bob Martin, but he kind of cropped them from various sources himself. And they're true today, right? Like they're interesting ideas about how to write clean code. And as someone who comes from a bit of a non-traditional background, they were kind of new to me, so it was fun discovering them. Maybe if you learn this stuff in school, it's boring. But for me, I was like, oh, no, this is actually really useful. And so I'm hoping to just talk about some of the design ideas that I thought were really cool that came out of that. And I also have a debt of learned a lot from Dave Cheney, who talked about solid design principles in the context of Go in a keynote he gave at GoLang UK in August 18th of 2016. And I say that because you should all listen to it. He's a great speaker, and he does a better job than I ever could. His focus is on Go as sort of like a programming language, kind of how it enables you to draw on some of these concepts. I'm here trying to apply some of those ideas to the specific context of writing an API. And I think a lot of what I'm saying here is my own opinion. There's definitely many ways of interpreting some of these concepts, and there's definitely lots of different ways to do it right. So if it's helpful, great. If it's not very helpful, just clean your ears, pretend like you haven't heard anything, and we'll all be better for it. So again, why apply these ideas to APIs specifically? I found, for me at least, working in like my professional experience, that often when you're developing APIs, it's very iterative. It's often, there's a lot of time pressure. So design ideas are the first thing that goes out the window when you're going back and forth with maybe a front-end developer or just working with product. So having a roadmap and some good design ideas, they don't have to be fancy. It's better if they're not, but just some simple ideas. Oh, I could try this. Maybe this will help. Maybe this will make my code a little bit cleaner, maybe a little bit more extensible. So yeah, ideas about maybe some of these ideas will help us write more like modular code, more extensible code, stuff like that. So the first principle of solid is the principle of single responsibility. So as Bob Martin would say, a class should have one and only one reason to change. And we can kind of take that and kind of, it seems obvious, apply it to the context of building an API endpoint. So a given API point should have a single job. It should do one thing. Duh, right? It seems obvious. But I think if you kind of consider that a little bit more and maybe flip it around a bit, we can think of it a little bit differently. So one thing to consider when you're writing APIs, you want to do as little communication as necessary with the front end, right? You want as few requests as possible. And if you're having one endpoint and it has a responsibility, you want to try to make sure that it's focused on doing that well, and that you have one endpoint that is extensible to all the different cases of that responsibility as you can. So it's easy to get very abstract, and the temptation to abstract away from useful details, I think, is a dangerous one. So to help kind of talk through some of these ideas, I've gotten some examples of what I think might be a better and a worse way of writing an endpoint. And what does the solid, the S, the single responsibility teach us? Well, as Bob Martin talks about it, when you're writing a class, and obviously Go is not a class-based language, but in this case, an API endpoint, it should have a single reason to change. And so in the case of, let's say, an example of an endpoint that is giving tickets for like a Jira or an Asana, whatever, kind of board where you have like a to-do set of things you have to do, you want an endpoint that will just deliver an array of objects to the front end. Each object, maybe it's something that you have to do, right? So if you can think in terms of the S of the solid principle, you want to have a single endpoint that's job is to supply those objects. You can change some of the details of what that object looks like. You can modify that single responsibility, right? But you shouldn't be messing around with other endpoints to provide the same object if you can help it. Better to write a single extensible endpoint that can handle variations of different types of endpoints. So let's say you have blue endpoints or blue tickets and yellow tickets, or shared tickets and personalized tickets. Really, you should be thinking far enough in advance that you're going to have one endpoint that can handle all of it. I suppose there's nothing wrong with having bifurcated endpoints like this, but I found in my personal experience, to the extent that you can kind of capture this S single responsibility principle, you're saving yourself some pain in the future. You're writing code that coheres more, right? So if you have more opportunities for code reuse, you're kind of helping yourself, you're paying a debt to your future self if you can kind of coalesce things. So yeah, so that's my take on what we might interpret from that principle. So the O is the open-close principle. So Bob Martin says software entities should be open for extension but closed for modification. So in the context of Go, Dave Cheney says we can think of that as instructing us to compose simple types in a more complex one using embedding. So this one, I think, really, for me, is a key idea that's helped me a lot understanding some good design patterns. And I built a little example of what I think. Is that, I can't really see, is that legible at all, or is it way too small, eh? Let me see if I can do a full screen. Can folks see? Oh, yeah, that's better. OK. So one thing that I found really useful, so a common problem that I've had is you have very distinct types of a thing. So in this case, of our ticket app, different kinds of tickets. It doesn't really matter what abstraction differentiates your different types, but it can be very tempting, I think, to have kind of spaghetti code, where if you have different logic for different types of things, let's say different ways of getting it from a database, different ways of formatting it, different ways of enriching the data, depending on some abstraction, it can be easy to have code that maybe handles everything using Boolean logic. Maybe if it's a blue widget, do the blue logic. If it's a red widget, do the red logic. It can be very easy to have an endpoint. If you're following that S, the single responsibility principle, you're having one endpoint do a lot of work. You very quickly end up in trouble if you're writing code like this. I see some people nodding their heads. I've been in this hell, this spaghetti code hell, and I've done it with gRPC services. I've done it with more RESTful services. It's easy to do, and it can happen quickly, and you can get there without even realizing it. And then you're like, oh man, I really regret my life choices. So another way of handling things that I found I like is having a kind of a type conversion interface as a field on a struct. And what you can do with that is have different structs that implement that interface. So for example, you might have a query object that's the request body, and on that type field have an interface that provides a few methods. Maybe build a method to validate, a method to build a request to a driver, and maybe a method to parse the results, something like that, right? And you can implement these methods in various ways. That's kind of what interfaces are there for. But I think it's a really powerful tool in the context of building APIs, because what it gives you is the ability to have a single responsible query struct, like the request body in this case, and then have different types that implement different kind of business logic, but you're still respecting that first principle, right? You still have one query, one struct that you're returning to the front end. The difference is you now have given yourself a bit of wiggle room, a bit of room to breathe, and you have this nice type switch here when you unmarshal your request body, where you set the type, and you extend that type in one place, and voila, you're happy. You've got your logic in one neat little package, and if you want to, your company acquires a startup, and you have suddenly a new database, and everything's just completely screwed up. Well, your API doesn't necessarily have to change in that many places. You just extend your type switch there. The business logic, if you've thought about it enough, doesn't really have to change, and you're happy. If you did this ugly thing, you will find that there are lots of places in your code you may not even remember need changing, and yeah, you're in trouble. So the L is the Liskov substitution principle. This one feels a little abstract to me. I didn't touch as much of a chord. Maybe for other people, you might like it. Everyone has different tastes. But it basically says that derived classes should be substitutable for their base classes. And this principle is require no more and promise no less. So we talked about how we have this single struct that's your request body, and then you have a field in that struct that's type conversions that allow you to implement different business logic to return whatever kind of response that you've agreed to return. The issue that you then have is, well, what should be the methods on that interface? Like what kinds of business logic do I need to do? No one's omniscient. It's very hard to know in advance every single step of the process that you're going to need to do to get the data from whatever data store you might have and to return it. So when you're designing interfaces, it becomes very important to try to think like, okay, well, what at a high level, from a bird's eye view, what do I need to do? And what's a level of abstraction that's going to be easy for me to extend? It's going to be easy for me to build on top of. It's going to give me enough room to accommodate a lot of change, but not be so general as to be effectively useless, right? So here's an example of an interface that might be doing some of this business logic I'm talking about, right? So to me, the Liskov substitution principle is asking us to really consider how we define an interface, to really think through the different parts, methods that you might be calling, and to try to do it in a way that's generic enough that it's going to serve you well in the future, but that's not so generic that you're not taking advantage of code reuse. So I think this is actually a really powerful step when you're designing any kind of an API, is to really think about, like, if I were to try to really get down to brass tacks, like, what do I expect might change, and how do I kind of think about things from this view of, like, what are the core steps maybe that my endpoint needs to do, and how do I kind of abstract that to a high enough level that I'm capturing something useful, but not so much that I don't get a code reuse. So for me, the good example would be if you have a function that gets data from a database, probably in a lot of cases, you want to have very similar logic doing that at the end of the day that's doing that query. You want to have your driver be written in a way very easy to have like one call, so that your code is sort of ending up in a single place when it's talking to a database. So maybe you have an interface that defines how you prepare the query to the database, and then a way of understanding how to parse the results. And again, this is more of an art than a science. I don't think you can really get it perfectly. And it's also not that big of a deal if you later tack on extra steps. But I think you really want to avoid defining interfaces that have a million different steps to try to get some useful abstraction. And I kind of like this, to me, like the sort of like creative arts side of my brain is like, this is an interesting problem. Like, there's not really a right solution. I don't think there's a perfect solution in any real world use case. But it's an interesting way to think about, like, okay, how do we build an endpoint? So this is the last one, or the next to last one, the interface segregation principle. So clients should not be forced to depend on methods they don't use. And then we have the classic saying, a great rule of thumb for Go is to accept interfaces return structs. So if you listen to Dave's talk when he uses that quote, which is kind of, I hear it all over the place, he delivers it with a grain of salt. He's like, it's nice for Twitter, it's not always true. So let's see here. Okay. So here we have a query struct. We have our type conversion field that we use to handle some of the business logic. We have a couple of fields. Here we have a single a method on the query called do that implements the steps of the interface that we need, of our type conversion interface that we've defined before, thinking about these ideas from the Liskov substitution principle. And then we call like this driver method, like I said, maybe we just decide not to abstract that away in our interface. So our query is always calling the same method to the driver. The difference is determined by our type conversion field, which is set up the business logic. And then we return the results of again, this sort of interface abstraction of parse raw ticks in this case. I just made all this stuff up. I mean, it's kind of meaningless, really. But I mean, like the names of the functions and stuff. Anyway, I think that's a better yeah, so better to, what was? Yeah, so instead of trying to basically, I guess my point here is to pass in an interface to the get method of the driver. Sorry, lost my train of thought there. Pass in an interface here rather than passing in a bunch of independent fields. So that's sort of a simple Go design principle, and not anything I think essential to the idea of an API design. But I think it is useful to remember that in general, we want to try to have these, the principle of accepting interfaces so we don't have to kind of stuff in extra parameters to old driver queries. We're not sort of like adding in later, expanding a function signature. That'll cause pain. So that's my take on that principle. And then dependency inversion principle. So high-level modules should not depend on low-level modules. Both should depend on abstractions. And then abstractions should not depend on details. Details should depend on abstractions. I love these like weird axiomatic principles. I don't always know that it's like you hear that and you're like, aha, like I understand how to program. But it kind of sounds nice, and maybe there's something there. So I was sort of thinking about this, like in my free time while I was like thinking about this talk. And one thing I thought about was one thing I think is really powerful is to really take the time to build out like a full suite of helper functions that are being used across whatever your repository, trying as much as you can to abstract like really common tasks into simple helper functions that you can reuse in different places. So maybe if you're using, depending on the logging library you use, maybe there's some common boilerplate around logging that you find crops up a lot. Try to standardize it into a helper library. When you're reading and writing responses, maybe you're sending a JSON response, maybe you're interacting with Hades rules or something, try to abstract that away into a helper function that you use in other places. I mean, it seems obvious. It's definitely something that is nice to keep in mind as you're developing code, and sometimes these simple things are useful to just repeat. So yeah, so that's all I've got. I hope that was useful. Hope that was something there for folks. So let me know if you have any questions, or yeah, whatever. That's it. Nice. Oh, yep.
Since you've been doing this for 2 years, which of the SOL IND have you found the most useful in embracing an API that's really resonates with your users and really is accessible?
So the open close principle, I was writing a lot of spaghetti code, and I knew that was bad, but I really didn't understand in the context of an API that was changing a lot, because that was our dev cycle, was a lot of like front end, back and forth, and we wouldn't always know what we needed until we needed it. And so it was really hard not to have just spaghetti code, like really hard to maintain, and a lot of these Boolean logic would crop up in weird places, and that's kind of the smell of it. It's like, oh, that's not good. But I didn't really figure out a pattern that really worked for me until I started thinking about that. And it was a big win for me when I started using these like field conversions on structs. I mean, for all I know, that's like an anti-pattern, but for me, it just really changed the way I wrote code, and I could create these like really neat packages that were really extensible. And I think it might speak more to the kinds of problems that we were dealing with at Hootsuite at the time, like different social media providers, different APIs, all ending up in the same database. So maybe this isn't super generalizable, but maybe it is. I don't know. But for me, that was a big one, and just really like having that flexibility. And I never really understood interfaces, the power of them, until I started doing that, and I was like, holy cow, like this is so powerful. So yeah, I think that was the moment, and then the seed of the talk, really. Everything else was cool, and kind of learning some of these principles, because I didn't do a CS degree, so I don't know, maybe they teach this in school, but for me, that was like really eye-opening and powerful. So thanks for that question. Yeah?
Comment. So one thing I also, my team at work just found when we did a bit of a rewrite sort of in this fashion,
Yeah.
was that we had a lot of structs that were being exposed to each other.
Mhm.
We started seeing like really disgusting like chain of like getting stuff out of each other to like call methods, and that got really gross and hard and fragile.
Yeah.
So I think it really helps with that. The second thing as a question to you
Yeah.
is there's like the Google developer guide for like code reviews or whatever.
Yeah.
And it says like the biggest thing is to not write code that you aren't using yet, or like
Nice.
and like not to code for the future is like the number one thing not to do.
Yeah.
Do you have a good way of balancing your interface writing to avoid doing that, or do you just kind of try to make it as solid as possible?
Yeah, it's a good question. Well, one thing that's nice about the approach that of using these interfaces, we use a library called Mockery, and we generate these mocks. And when we're writing our tests, we have to implement mocks for each function call, right? And so when I'm writing tests, it can be a really nice place to sort of test that L principle, the Liskov substitution principle, which talks about not having messy which I have interpreted, maybe very wrong, as not having very messy interfaces. Because if you're writing your tests and there's just like 6 calls to like mock dot on this function, this function, this function, and this function, and it's like I'm doing something wrong. And so yeah, I find when I was writing tests, like I begin to feel this like slowing down. I'm like, oh, this is taking me too long, and it looks bad. So there was that kind of like code smell that helped me think about like, oh, I'm doing something too much, or I'm not generalizing enough maybe with the way I'm thinking about my interfaces, and then coming back. So just even having it in mind. But yeah, it's a tough, I don't know that there's like a perfect answer, but yeah, it's a good question. Yeah, thanks.